The final design product. They were not given specifics. They were given a general description of what was required. Okay, so we've got essentially a cable winding machine over here, which is our crane, where they have to lift 3 objects, place them, come back, lift the next object. We've got the elevator, has to go between 3 floors. It's only programmed for a person who's outside the elevator, not inside the elevator, so the buttons are on the outside and the floors light up. Need to light up when they get to that floor. We've got an automated cookie topper, where the cookie, they have to put it in the packaging, it slides down the ramp, they have to top it, it has to come down and be packaged in a box. Okay, and then last is the non-Amazon delivery system, which there's an assembly line here putting products off. They have to go and put it in the bin. The last thing that has to happen is it's the end of the shift. The assembly line has to be cleared and all the parts put in the bin, and it returns to start the next shift the next day. So all has to be automated except for we've got a couple of buttons. We have to push the buttons on the elevator. We have a button that has to indicate the end of the shift so that it does one last run for this one. And like I said, they were not given specifics. The first thing they had to do was, with their partners, is come up with a design. We've had lots of redesigns, which they will go into when they talk about how they built it and the functionality. But Aubrey and Cole are up first.
I'm Cole Kelly. I'm a junior and I'm a senior, class of 2022, and I want to go into, I'm thinking, environmental engineering, maybe civil. I really don't know where I'm going to go to college yet.
I'm Aubrey Jones. I'm a senior. I plan on pursuing agricultural engineering. I'm going to attend Bevel State for 2 years, then transfer to Mississippi State. So this was our first idea of our crane. As you can see, we've changed a few things. And it was just pretty basic. Had a motor running right here. It would run to the end of our deck right here, our boom. And we would pick it up, and this was just our basic, very first, this was after Mr. Goins told us what we had to do. This is just our first thoughts. You have anything else?
Really, we added counterweight and just how to get it to turn, to rotate. I'll let you do this. This is our code. You can see it's pretty long because we couldn't use any repeat or forever loops. This, just setting the torque and the velocity and everything. Let's see. The motor 2, that is what turns the winch. The motor 11 is what spins. It's this, and then the motor 1 is the conveyor belt. So we just have it, basically it starts in place, brings it up, and brings it over, lowers it, brings it around, lowers it, the conveyor belt comes through, and then brings it up and repeats the process.
Ready to run it? say this project has given us lots of headaches because we can't, this is really uncontrollable and we can't have any consistency based off the swings. So it's caused us a lot of problems, but I'm glad to see it work.
A lot of independent variables can change.
All right, any questions for them?
If you had more time, how would you refine this?
Well, I was thinking about just completely redesigning this and making it more of a different style crane, where it's just getting rid of the ropes and just making this solid, just swing it down and have something to actually grab it and bring it up. But that's because we've tried like a tube and stuff to limit the swinging, but it can only be so short, so it really wouldn't have made much of a difference.
How many man hours do you think you have into this?
We started, what was it, last Monday? Or
Yeah,
before that,
no,
was
it
it
was-
last Monday?
No, 2 weeks ago.
It's been about 2 weeks that
So
we've been
probably-
working on just like designing stuff and then just going through ideas of building and how we were gonna do it, and then finally getting it to this point and having to figure out all that programming to get it to run right. We've probably ran this thing,
15, 16 hours.
yeah, we've ran this thing a lot.
Yeah.
Non-stop for like the past, this past week, we would run it non-stop the whole time we were in here. Like last Friday, my first block, they were doing an exam review and I exempted, so I asked Miss Moore and I came in here, worked on it then, finally just trying to get it to work. And so it's been a long time working on it.
Tell them about what you had to modify, we hear about it.
Up in here?
Yeah.
Oh, so what we're having problems. We had, before we put in this spacer and everything down here, we're having problems because these screws would get caught on this metal grating.
Rub that.
And so we went through some ideas. We ended up putting a bunch of stickers down here so it'd try to slide across. And finally, we put in these plastic spacers because we knew it would have free rotation on top of them to change that. And that helped us a lot because it was causing us a headache because we'd be able to pick up one, we'd go back and it'd just stop out of nowhere.
It's jolt.
Yeah, it was
Not
really
smooth.
jumpy, and so we had to figure out something to fix it.
Had to change the design of what we were picking up, quite a few trials, the materials.
Because we had aluminum bases right here, and they were having way too much swinging action, and so we got steel for more weight so that it would stabilize it more when it was actually on the crane.
We played with the counterweights in here, how much, where they were located, a bunch of different things.
My name is Lee Walker. I'm a senior, class of 2021. And what I pursue my career in is first go to college at Melbourne for 2 years and then transfer to Alabama into mechanical engineering.
My name is William Wolf. I'm a junior, class of 2022. I plan to go to Bevel for 2 years and then transfer to UAB.
To study.
Probably a discipline of engineering. So this is our original design. It was supposed to, we would set on the ramp and then it would go onto the conveyor belt, and then using the arm, it would swing it to the other side and drop it in the box. Using the wheels and motors, it would drive from the ramp to the box. This is the code for our delivery system. It spins for a quarter of a second, and then it stops and then waits for 14 seconds for the robot to completely go to the box and then come all the way back. And this is the code for the robot. It'll drive all the way to the box, deliver the tag, and then go all the way back. And then it'll do that for 3 times until the 4th time when the button is pressed, it'll do one more run and then come back and it's finished.
You wanna talk about that?
Yeah. Okay, so this was originally not our first design. Our first design we had 4 motors controlling each wheel to go forward and backwards with this brake. Then we changed it up to where it was rear wheel drive with 2 motors. Most of the problem was we couldn't get it to go straight. Then after that we used tank treads. It still didn't work. Because the floor is like very slick, and then we put it on the rug to where it would have more friction, to where it wouldn't slide as much and move. And
We finished the entire robot in about 3 or 4 days. The rest was spent trying to get it to go straight.
yes.
You have a single drive train on it now?
Yes. Just about 1 motor right here.
You ready?
Ready when you are.
So I press the button 1 time, it runs. I like this.
Alright.
Oh. And then for the last run, it'll run, the conveyor belt will run for 20 seconds.
There you have it.
All right, any questions? Now, their biggest problem was that,
Wouldn't go straight.
it wouldn't go straight because on the floor, especially when they had several motors, that was a problem. Because you have to synchronize the motors. And they finally came up with this chain system, which helped them out. But they went through World War II tanks to everything. to try to get to-
I think how many designs do we have, like 15?
Yeah.
Y'all had the whole lab.
Yes, we destroyed everything trying to get this thing to work.
Yep, they did.
What would you do differently?
Figure out a way to make it go straight without having to have the rug, and make it go a farther distance to where it fluctuate more properly.
Did you ever think about putting down guardrails?
Yes.
I thought that was a stipulation we couldn't put down.
They couldn't put down guardrails.
Oh.
Because essentially what a bigger project would have been is to have like 3 bins. So it has to deliver with turns and things, so we need to put the guardrails in. All right, we good? All right, who's next?
This was the original design. At first, we were gonna have 2 buttons for our second floor, so that if it was at the top, we'd bring it down, and if it was at the bottom, we'd bring it up. We had thought about putting optical sensors to detect a color, so that it would stop once it saw that color, but we eventually didn't end up adding that. We were gonna have a bar up here to bring it up and down, but instead we just had the motor and the winch at the top. And we were gonna have just strings that would attach at 4 corners and come together in the middle. That ended up being better just to have the one string attached in the middle. And then for our code, this one is the floor 1 button. So when you click the floor 1 button, the motor will spin to bring it up. And then once our distance sensor right
marked at the top, since the top of the elevator within 16.9 and 17 inches. It stops it and holds it in place, and then turns the LED on for 5 seconds. And then same for the floor 3 button, which is this one. And then for our floor 2 button, if the sensor detects it within 9.3 inches, it'll move down so that it goes to the third down from the 3rd floor to the 2nd floor, and then turn the LED on, and then if it's not, then it'll turn it up to the 2nd floor from the bottom, and then turn the LED on.
My name is Ethan Flynn. I'm a sophomore in high school and I plan on basic chemical engineering. As he said, we used to have 2 buttons here, but we figured out how to use so that the second button would bring it up to both top and bottom. With our plan with the strings, the elevator would always get caught on the exterior, so he added linear motions so that would slide it up easier.
Functionality. This was quite a hassle, I'll say the least. The structure itself was not hard to build. It started out pretty simple, 4 corners and have an elevator. We had our elevator built first so we could build from the ground up from it. Our first idea, like Bryce said, have a string in each corner. Well, then we come to the conclusion you have to have 4 different motors. Well, if they're not synchronized, you can go up an elevator like all wobbly and things like that. So we decided to do track on the side. It would have tracks on each corner, and you'd have a gear like on their system where it would turn motors on the inside and it would drive it up. Well, this kit is not very precise, so that wouldn't work. So we decided to put this linear motion kit on it. It did not work at first, and then we finally had the idea to get a sense of lube, and it went very well. And Mr. Goins didn't think we could get it done in time. So when we did get done, he said, "I bet you won't put elevator music on it." So I took that as a challenge, and I put a speaker inside here, and it plays elevator music to prove against him. But it was quite a hassle. Both of them he done a very good job coding. He helped out a lot getting the structure in. Without these two, this would not be the way it is now, because my original design was nowhere near this, and it was not very functional. But I guess we can show it all here. I think we did succeed very well, because I asked Ms. Moore at the beginning of the project, I said, "Would you ride this elevator without signing a waiver?" She said no, but now it's okay, because she will.
You'll notice the LED lights.
Yes, there are LED lights
Take
on
it,
the side.
take it straight to the 3rd floor. And then all the way down.
What are the 2mm wrenches inside for?
That's his people. That's what he calls people. It did go slow, so you don't have to hold on to any rail on the side. It's kind of free flow.
Any questions?
Ethan, I know you did flash, but what do you want to do?
I've looked into it, and I'd like to be a software engineer. I've looked in the agricultural field, and it's more plant-based stuff, and I'd like to design more than work with plants. But I'd like to go to Bevel for 2 years, and then Mississippi State. It's almost like Aubrey's career path.
No, I didn't catch your name.
I'm Bryce Wilson.
What do you want me to do?
I was thinking either computer or software engineering. I'm not sure what college yet.
And what grade are you in?
I'm in 11th grade.
When you said you were gonna put a single cable lift on it, I really thought it
to swing around like a crate, but putting the tracks on the back I thought was real smart.
Originally, we didn't know we had that, so we originally started out, this structure was gonna be, you know, pretty tight up against it, and we had axles and rollers that we put along the side so it would roll up it. Well, that did not go as planned because these screws bent out and the motor wanted to bind up, but these tracks definitely keep it in line. There's red, I don't know really what you call it, it guides it along the track, so it stays sturdy, and all you need is one rope, because we were afraid if we put 4 on it, you know, like I said, it would wobble and it wouldn't go straight up, but that really helped us out. It was terrible getting it level. I can't tell you how many holes we had to drill just to make it go up straight. Because for some reason I have a problem with trying to redesign, and at the last second I redesigned it and it would not go up, and we were all going ballistic, and it was, but it,
And what was one other problem with the alignment?
What about the other one?
What was the other one?
You like the hammer on things?
He decided he was gonna hammer those plates around, but what he didn't understand was the entire structure.
I had to put all these walls around it so nobody could see the inside, so it actually at least looked half decent. Because if you look straight from the top down, it's all like,
Yeah. Because somebody decided hammering would be the best way to modify his element.
Is your lift cable wire or monofilament?
it's a fishing line.
It's mono.
Mono.
It's mono.
Well, the elevator you supposed to touch the glass.
Yeah, sure.
I like taking challenges, and I wanted to show that it was possible. It was possible.
Are we good?
I'm Joshua Mix, and I'm a senior here at Jackson High School. I plan on going to Bevel for 2 years and then swapping over to Auburn to do chemical engineering.
My name's Destiny Hernandez. I'm a senior. I will be attending JB, and I plan on becoming a doctor.
This is our initial design. As you can see, it's changed a lot. But here we had it where it would be like a tube that would drop cookies down into it and then land on the conveyor belt. But we decided to change that to a slide because that would make it a lot more simple. And then it would go down to the conveyor belt and it would have a tube for the toppings also, but we decided to change that to a conveyor belt. And we have it set on like a timer. And then at the end there, it'd slide down into like the box, which we still kind of have that, but we have it where it goes that way instead of just goes straight. And that's basically our initial design. And then this is our coding.
Okay, so for our code, we have this motor right here, our motor 1. It sets the velocity to 25% because 50% is just way too fast for it. And we have it rotating for 0.57 turns so that it will stop right below this conveyor belt right here. And then this conveyor belt will rotate and drop the chocolate chips onto the cookies. And then it'll rotate again onto this conveyor belt and push it down into the box.
And for this, we have the conveyor with the toppings up here. Then we have the one that the cookie slides down onto and then pushes it to this conveyor belt. We have these 3 bars right here to help keep the cookie from flopping over, because it would do that a lot. And then we had to put up these little blockades so the cookie doesn't fall off. And then we have the slide at the end that makes it down into the packaging.
You want me to talk on this? Okay.
All right, questions? they had a lot of struggles with alignment. This is critical that you get the alignments right. And they had a lot of struggles first with the alignments, but we've been a few
Got a lot of
axles.
flexibility in the cupcake cup.
They've been a lot of axles and maybe almost burned out a motor, but got it to work. So it would be part of, the cookies would be manufactured down here. They would come on a conveyor and then they'd slide down to the topping area, so, and then be packaged.
Dixie, what was the hardest part for y'all?
Well, the hardest part was this part right here. If it's like slides down too far, it won't get back, it'll keep getting down. So we've changed the slope of this ramp.
Almost like 20 times.
Yeah, it was a lot.
And then they had a problem with varmints eating their chocolate chips all the time.
I'm happy that it's over today, so now we can eat them.
Yeah.
He got done a lot quicker than he thought, so he wanted all of us to put all our ideas together.
Yeah, I told them they were gonna have to put all of them together and make one big assembly
That would be cool.
to process the cookie, lift the cookie, deliver the cookie, do all the stuff together, but but that is that's their final project. So
How much fun have y'all had in here?
Oh, I've taken 2 semesters in a row with Mr. Goins, but I've had a great time with Mr. Goins, and I could say he's definitely one of my favorite teachers.
I totally can't believe till at least we graduate.